All right, it is 12 o'clock. Good afternoon, everyone. Let's get started. How you folks are doing? It's Friday, so TGIF. I'm not bad. Yeah, I'm happy it's Friday. I thought it would be an easy week because of the holidays, but with their exam on Wednesday, I don't think it was easy, and I'm pretty sure it wasn't easy for you either. So how did exam feel? No more exams. Wow, that's a bit radical. I don't know if that's something we can do. Was it so bad? Syllabus questions bad. Oh, I thought that they would be the easiest because they should all make sense. When do you get your grades back? Hopefully within a week. Around Wednesday next week. But we are having some issues with submitty. And I know some of you are actually submitty developers, so you know what I'm talking about. So hopefully we get over all the submitty issues and start grading. This exam one we might be a little bit behind. So we might get your grades back by the end of next week, but we are still trying to, stay with our uh, desired date, and that would be Wednesday. Yeah, writing code is hard. If you have to do it by hand, I'm totally with you. But we have to somehow test that your ability to write code. Right. This class is a lot about writing code, and if we could somehow give you laptops with a compiler and everything, but no internet access, I think that would be perfect, right? But for obvious reasons, we cannot allow people to use their laptops because people would communicate with each other, people would use Google and Stack Overflow and whatnot. So that is the reason why we have to kind of limit access to electronic devices or not allow access to electronic devices. Yes, yeah, I know. Someone finished in like, I don't know if it was 20 minutes, but definitely someone finished in like 30 minutes. Yeah, that was pretty amazing. And that person's answers were not blank, so they were real answers. So yeah, I mean, if I had laptops to give to you, I would totally do that. Unfortunately, that's a little bit beyond of what I can do. Yeah, cut internet in a given room. If we could do that, that would also work. I have this idea, for many years that RPI should have like a testing facility, like special room with laptops where students could just set their time that they want to come to that room, take their exam, and then the exam would be administered by this testing center. So uh, their instructor would let their administration of the center know what kind of tools should be allowed, internet, no internet, compile, no compile, that kind of stuff. And then students would just, sign up for the time slot and go take their exam there in this testing center. But it's it's a good idea, I think, but I don't think we're gonna see it implemented anytime soon. All right. With that, just a heads up. Next week is our week with their lab. Their lab handout will be posted on Monday, and there is no exam next week. And we're just continuing with the homework. Thank you for reminding me. The homework is due on Tuesday. Can I mute that person? Sure, I'll try. It's probably someone who dialed in from the phone. Is that better? Yep, I muted them. Yeah, thank you. End of the day, 11:59 EDT, 11:59 p.m. EDT. Submission open. Yeah, I should be able to open, to verify the auto grader tonight. So submissions should go live. The page should be visible to you tonight or tomorrow morning, the latest. Okay. You got an exam passed due on submitty? No. If you took your exam, on Wednesday on paper, that's all you had to do. It is. I don't know if, what submitty shows to you, but there's like a problem with the dates. There is really no due date for you, for the exam on submitty. But we have to kind of let submitty think that there is a due date, because otherwise, some of the dates are messed up. So it's complicated. The short answer is don't worry about exam on submitty. It's nothing that you should be concerned about. It's a placeholder. Yeah, once grades are out, you should be able to go to that gradable, and there you should be able to see your graded exam. That is your PDF that we scanned from your paper exam, and the rubric that would tell you, for each of the questions how many points you got, and then it would compute the total. So that's that's what is going to be once we release the grades. There is office hours today from 4 to 6. I believe so. Yeah, so we run office hours as usual. The only change I had to make to my Friday office hours, I had to move them to 2:30 to 3:50 p.m. Just because I'm holding them in my office. As you can probably tell, I'm doing this Webex lecture from my home, so I need half an hour to get from home to my office, and that's why I had to move my office hours, to 2:30. But other than that, Friday 4 to 6 office hours should run as normal. For the room assignment, I don't remember, but we got some rooms assigned for some of our office hours, and I updated their file with a schedule, so it is current. So if it says Emma Seaton such and such, that's currently accurate. Are there any problems scanning pencil? Were there any problems scanning pencil? Not sure I understand. Yeah, for their office hours, let's check what it. Let me start sharing something so that we are on the same page. And I want to see the chat. And if we refresh the page, go to our office hours, then yeah, it's Emma Seaton 127 with our TA Nathaniel. So yeah, 4 to 6. Yeah, it's 4 to 6. It should be 4 to 6, right? It's a little, yeah, it may be giving you an impression that it's just 1 hour. I believe it's well, let me actually check before, because there might be changes that I'm not aware of. Let me check our main internal file. All the schedules and Nathaniel, yeah, is listed for 4 to 6 p.m. office hours, and it's going to be in MS Eaton 127. So it is going to be in person, but of course, people who want to join from Webex, of course, you're more than welcome to, right? So we do not insist on in-person attendance for office hours. So it's completely up to you whether you want to drop by or connect remotely. I wrote in pencil and the scan looks good. Yeah, so if we didn't limit what you could use on the exam, pen, pencil, anything would be fine. If the scan quality is low, then we would dig out your paper copy and it would be the grader's problem essentially. But of course, we ask you to try to do your show us your best penmanship and try to have sufficient pressure on the pencil as you print or as you write, so that it is easier for us to read the scans. Yeah, the graders will curse you. No, well, they might say a word, or two, but if that is a common problem, I will definitely mention it before the next exam. So, but so far the scans that I have seen, I think they look pretty decent. Where is the Anna Seton building? It's next to the library. It's like between the library and the Sage. What if you only have very light pencils? Well, can you get another pencil that is not so light, or borrow it from someone? I think that would solve the problem. Or yeah, I mean you can use a pen, but with a pen you cannot really erase it. So that's why I see many people prefer pencils, because you can erase. Okay. Yeah, Webex needs a better UI. I agree. Okay, so I think yeah, that's all we have to discuss about the exam and their upcoming homework and upcoming lab. So let's turn to our topic, and we are just continuing with the same topic that we started last week. And that is C, and we will also start talking about Linux today. So let me yeah, and by the way, I don't know if any of you noticed. Yeah, some of you did notice that the first poll for today is already open. So lecture polls, we agreed to run them for late days as a means for students to earn late days, extra late days. So the first of the four is already open, and I will open the rest as we go through the material. And someone asked me last time to review their correct answers on the previous polls. So let's quickly do that. So if we look at their results of the first poll, which was their reason why their command was not successful. So let's see what the answer was. Oh, let me open the chat again. Every time I switch views in Webex, it changes all the windows to defaults. All right, so yeah, this code actually does compile, but it fails linking because it is missing their -lm link with math library. That's what it stands for, command line argument. So the code compiles, but their executable cannot be produced because their linker just doesn't know where to find that math library, and math library is needed because there is an sqrt function referenced. Okay, so this is the correct solution. So for this one, I will go with Vox Populi, Vox Dei, so voice of the people, voice of God. So yeah, I agree with the majority of students that I also believe this is the correct answer. Okay, and then their second Paul, is I was joking that there's only one correct answer. Of course, this one is a survey type question that there are no, any answer you picked would be correct. So it just I'm polling you on what your favorite editor would be. So the majority voted for Sublime, but VS Code is a runner-up. It's really close, and traditional Unix choices, VI or Emacs, are not really, not that many people use them so far. But maybe that would change, right? As people are getting more into Unix environment in this course, and maybe more people start using VI or Emacs. No one voted for Kate. I actually kind of like this editor. It's simple, but it's cute, I think. And no one voted for Nano, right? Which is very basic, but very fast and very small. All right. Windows Notepad. 8 people voted for it. My personal opinion. Feel free to disagree. I would try to stay away from Windows Notepad, stock Windows Notepad at all costs. I believe it's the worst of all the choices that were given. Any of the other choices would be better, but anyway, it's a matter of personal preference. Okay, so Atom. Actually, I did have it in the list. And code blocks. Code blocks. Yeah, sorry about that. I forgot. I forgot about those. There are tons of editors, so it's hard to remember to list them all. Anyhow, so let's see if so people are voting for the hardest exam problem. So that's good. So we will see what the results are, and then I want to let all people vote before showing the results. I don't want to influence people who have not yet voted. All right, so let's go back to our slides. And let me see. Can you see my slides? I put them in the full screen mode. Okay, cool. So here are some useful macros that you can use in your C programs. All right, so they are called predefined, meaning that you can just use them. You do not have to define them. So they are expanded. They are processed by the preprocessor, and a few people were a little confused on the exam around their wording of the question that was saying, please write a complete C program. That means, define all, include all necessary preprocessor commands or preprocessor macros or preprocessor stuff. So preprocessor is in C and C++ world and in some other languages as well is sort of a separate tool. It's not a compiler. It's just a tool that pre-processes your source code before it is given to the compiler, and it performs. It works on your source code. So if you have a macro defined, then the preprocessor would replace the name of the macro with the value that you defined. For include directives, it would actually take their file that you are including, like a header file, and include it in your source code. So this is what preprocessor does. And preprocessor directives are those things that start with a sharp character. Okay, so just wanted to mention to make sure that we are on the same page regarding preprocessor and what it does. Yeah, there are 2 underscores. And as you can see, in some fonts, for some characters, there is like no break between 2 characters, so they look like one longer character. So you just basically have to see and compare with the regular width of other characters. And on the exam, by the way, there was a couple of people asked this question. Like there was a code example where there was double equals that looked like that looked like there's no space between equal sign, two equal characters, so they look like a single long wide equal sign. But you can easily tell that it's not a single equals because one line above there was a single equals in the assignment, so you could clearly see the length, the width of the character was different. So shorter one, smaller one was a single equals, the longer one was a double equals. So hopefully that makes sense. And yeah, this is a standard form that the standard font that LaTeX LST environment uses for C language. So we just have to to bear with it. Okay, so that's yeah, those are the macros, and let's actually look at Y3Ms for a month in date, because it's going to be a string like September, I believe, would be SEP, and we will see an example shortly. Yeah, exactly. Thank you. Yeah, I am so happy people are answering other people's questions. Yeah, please keep it up. It helps me because I might be missing some questions. Yeah, somebody answered a question about double underscore, whether it's for all macros, and so that question has been answered. Thank you, people, for being active. I really appreciate it. All right. So. And yeah, now let's look at some examples. This is an example from, basically the material that we covered last time, but didn't really have time to go through an example, fgets. Here, as you can see, we use fgets to read from a file. So my file is a file object. So the type is file in all caps. So as you can see, it's actually, technically it's a pointer. And you don't really need to worry too much about what it is. The thing that you need to know is if you are successful in opening the file with fopen, then fopen will return this handle to you, and then you use that as a proxy for your file throughout your code. So you see fopen, we open the file, specify the name of the file, and R, this means read only. If you want to write to file, you would specify W. If you want to append to an existing file, you would specify A. And then fopen, if it opens the file successfully, returns this file star to you. You save it in a variable, and then you use it from that point on to access your file. Then in the end, you need to close the file. If you don't close a file that you are just reading, it's not going to be a big deal, although we prefer to be disciplined and close all files that we are opening, even if if we are only reading from the file. But for a write file or append file, you definitely need to close it. Otherwise, it may not save everything that you've added to the file. So it's easier just to always close the files that you open. And if the file was not opened successfully, fopen returns null, and we check for that, and we print a message, and we quit. So if the file was opened successfully, we read from that file line by line. That's why we use fgets to read each line from the file. We assume in this example that each line is not going to be longer than 256 because we have, as you can see, a statically allocated buffer of 256 characters. And that actually includes a null terminator. The effective max is actually 255. And then we use scanf. So it's like your usual scanf that you use to read from standard input, but this one allows you to read from an arbitrary C string, and this is the buffer that we pass as the first argument to scanf. Okay, so as you can see, it's convenient to use fgets with scanf, so they make up a real good combo. And then we just read these three variables as you would with a regular scanf. So that's it. scanf returns the number of values successfully converted, right? Because essentially you read from the line of text that was first read from the file and put in the buffer. So now you read that buffer and you convert these three values: name, age, and height. And if scanf returns anything but 3, it means something went wrong. It didn't read 3 values. So that's why we print an error message and quit. And otherwise, if everything was successful, we print what we read from the file. Okay, the name of the file is passed as the command line argument. So let's try to compile this IOC. And then we can run it. And if we don't specify the command line argument, you can see that it is not working, right? It's complaining that it could not open the file. So let's see what the file is. And I believe it is called peeps. Okay, and you see that now everything works. All right, and of course, this is just one of the ways to, to do file I/O and parsing the data that you read from the file. So people are suggesting other ways, in all homework assignments and on the exam, you can use any feature of C and standard C library that you like. Even if we didn't cover it, if you use it and if you use it correctly, it's perfectly fine. So at the minimum, you need to know what we covered in the lectures. But if you know something else, and C is is a pretty big line. Well, C is not as huge, but the standard library is pretty big. So there's no way we could cover it in just a few lectures. So there's a lot of stuff that kind of we have to leave behind without ever looking at it. So if you happen to know that stuff, or if you if you learn about this stuff from SciBooks, or by reading their some tutorials on their internet, it's totally okay, right? But it has to be plain old C, right? We are not using C++ in this course. Yeah, exactly. You can use whatever feature you like, as long as it is from the standard library. So, please do not attempt to give us, C++ code that uses Boost, or C that, even if it's C, but it uses some, third-party library. That's that's not allowed. It has to be, standard C library. Yes, you can use exit in function. Or just in main. So exit is just a function, and the value that you specify as the argument is their so-called return code, or error level, as it is known in Windows. Yeah, ZyBooks uses fscanf, exactly. Okay, so 256, the character limit for a single line. What is the significance behind 256? There is no significance in this case. I mean, 256 is a cool number, right? Because it is the number of values that you can represent with 8 bits or 1 byte. But in this particular case, there is no real significance. We just assume that this is the longest line that might appear in our text file. You could have made it 1,000. You could have made it 50. Well, it has all our lines are short. So it's a magic number. That's why it's actually bad. So in this simple example, it's okay, I guess. But generally speaking, magic numbers are bad because you in many cases don't have a good justification for why you came up with this number. And this is a good example, right? I have no justification why it's 256, right? I could have gone with 1,000 or 50, right? You have to make sure that it's it's larger than the longest line in any possible file that you can feed to this program, right? But other than that, it's just a magic number. Okay, all right, and so then. Here is an example that I wanted to show with those predefined macros. So you see it's double equals. And by the way, all those examples are on course materials, on the course materials. So feel free to run those examples, compile and run those examples as I'm working through them. All right, so it's called more printf, and one thing I actually wanted to do, let me demonstrate it with a previous example. Right, I'm tired of typing two commands, so I want to combine two commands into kind of one line. So you do this in Linux, you do this with a double ampersand. So it means execute the first command, make sure that it executed successfully, and then run the next command. Okay, that's what I'm going to do. And then for my next, it's called more printf, and I'm going to go with more printf, and then more printf, like that. All right, and you can see that, yes, it's SEP September. That's why it's MMM in our description there. Okay, yeah, so someone posted from from what they Googled, the limit due to all right, strings store the first byte holding the length of the string. Well, that's not a C string, right? So we discussed before, C string does not store the length. So the C string, right? Actually, as we discussed, there is no such thing as a C string, right? So it is actually a character array, and all characters are equal except for the last character has to be a character with code 0 code. We call it null terminator or null character. So the first character in the string is just the first character of the string. It's not the length of the string. Okay. So yeah, in C++, and other languages, things might be different, but with C, we only have character arrays, and the only way to compute the length of the string is start with the beginning of the string, and then go through the entire string, the entire character array until you hit a character with the code 0. And at that point, you know how many characters you've gone through, and that would be the length. Yes, so strlen does exactly that. It loops through the array, so it's a linear search. If you treat the string as an array of characters, exactly. Yeah, so, well, it depends whether it's efficient or not. It depends on the length of your string, right? So, and in C, there's no limit, like 256. You can have a string that is, this character array that has, 1,000 characters. So 256 is definitely not, not a limit for the length of strings in C. And yes, so if your strings are long, you might make your code a little faster if you save the result of strlen instead of calling it repeatedly. Of course, you have to make sure that your string doesn't change, right? If you change your string and you have this old value of strlen saved in a variable, then it is no longer valid. So you have to be careful with that. Usually, the performance gain would not be significant, except for maybe very long strings when you call strlen many times. In this case, yeah, might be. Are we going to be doing a lot of big O notation calculations in this course? Yeah, I would say a lot of. So this course is more lower level, so it's more about a lower level stuff. But as we will discuss in a little while, most of the ways to make your code run faster is avoid unnecessary loops, and in that sense, you need to have a good eye for where loops are, because sometimes loops can be kind of implicit. So you have to look behind every function call and kind of see what how that function can potentially be doing its work and see the big O notation behind that, right? So and it's just exactly the conversation that we are having right now about strlen, where their their big O notation for that would be a big O of n, where n is the length of the string. Okay, so yeah, you have to be comfortable with the big O notation, but we're probably not going to be using it as often as you were in the algo class, but definitely you need to know that. Okay, strlen and size off. Size off gives you the size of the variable itself. strlen gives you the length of the C string. So it is and we will see the difference, right? In that there is an example coming up, right? strlen can only be applied to strings, all right, to those character arrays. Size off can be applied to any variable, to any data type, to be more precise. Yes, so size off exactly would give you the size of the pointer, not the length of the string. All right. Good questions, excellent questions. I wish I had more time to answer them, but we have to move on to make sure that we cover what I planned to cover today. So, editors. Yeah, I'm not going to spend too much time on this. It's basically a matter of personal preference, and this is our pop quiz from last time. We already looked at C and C++. C++ is development on top of C, C++ added classes. Therefore, in C, there are no constructors, destructors, no inheritance, operator overloading, not even function overloading, and there's no new or delete. We have already seen examples that we do malloc and free. There are no templates whatsoever, and there are no strings or booleans. For strings, we already discussed, we use what is known as a C string or a character of an array of characters, and for Boolean, we typically use an integer. All right, and then again, C assumes that a value of 0 corresponds to false. Any non-zero value corresponds to true. Okay, difference between malloc and calloc coming up. Just wait a few slides. All right, you can do kind of object-oriented stuff, or what was the precursor to object-oriented paradigm in using C, and that is structures, structs. So if you think about C++, you can have data. What is an object, right? It's data and methods that work on that data. That's a very simplified definition of what a class is. And classes grew out of structs, but there are important differences between structs and classes. So structs are more limited. Classes are, more is a more recent development. So struct basically allows you to group data together and treat it as a single unit of data. Like, we want to represent all data about a student, so we group the first name, last name, ID, and GPA in what is known as a structure. Okay, so then we can use this data structure that we called struct student. So you see, we called it struct student. So this is, by doing this, we introduced a new data type in our program. Now that we've done it, we can use it. If you're not happy about having to type this whole thing, struct student, you can actually give this data type a new name, and we will see examples of that. You just need to use typedef for that. So we define variable Susie that has type of struct student, and once we've done that, note that there is no dynamic memory allocation anywhere here. So we just have, Susie would have these 4 fields that we defined, and their memory for those fields will be allocated on the stack, because you can see Susie is a local variable in main, and we do not get any free initialization of the fields of the struct, so we have to initialize all data members by hand. We can use, of course, any functions that might help us. Like here, we use str copy to copy this string literal to last name field of Susie, right? So if you need to reference the field or the member of the struct, you use the dot notation. So Susie dot last name will copy chapstick into this last name field of our Susie variable, and then we can, of course, just do assignment like here. Yep. Then we can have more variables. All right, we can have another student Sam, and then do the same thing with them. So here, this slide kind of highlights something that might feel very unnatural to you coming from the C++ experience. For pre-C99 standard of C, you have to make sure that you define all variables before the first executable statement. Okay, so this is a difference between standards of C. So in pre-C99, this code would not compile, because as you can see, this definition of int I, this definition of Sam, they appear after their call to str copy, and this is not allowed. So the idea, and it's like a very old, traditional, classic programming languages paradigm from decades ago, that you first have to define all your variables and then use them. So that's why older standards of C enforce this, right? So if you're using C99 or later standard, this code would compile just fine, so you don't have to worry about that. But you need to know about it, because if if you're using ANSI C, then you have to, or Kernighan and Ricci canned RC, then you might be surprised why this innocent code doesn't actually compile. And of course, it has a significant impact on the for loops, right? Because if you cannot define your variables in the header of the for loop, right, that means that you have to, keep track of the variables and make sure you're not, using the same variable for two different things at the same time. Can you do like struct students, Susie, Sam? Yes, you can define multiple structs, multiple variables of type struct. On exams, would we get points off for doing something that would work in C99 but not in earlier versions? No. On exams, it's fine to use any version of C. But it has to be C. It cannot be C++. I cannot stop stressing this. So wait, where is the int I being used? It's not being used, right? But we were trying to define, to declare I, and this would not compile in pre-C99 standard of C, right? You don't have to use a variable, right? You might just want to define it, define and declare. Okay, and here is an example for one of the differences between C++ and C. In C, you can totally do this. You can define and declare a variable in the loop, and the scope of that variable would be exactly that loop, which can be pretty convenient, unless you want to use that variable outside of the loop, of course. But in C, you must declare the variable before the loop, so you cannot declare I in the header of the loop, so you have to keep it separate. And then the side effect of this, or maybe the intended effect of this, is that I has the scope, whatever the the scope of this code is, right? Whatever function this code appears in. or if it's outside of any function, then it's going to be global, right? So that means that if you are able to keep using this I variable after your for loop, right? That variable still exists, and that variable has the same value that was last modified by your for loop. In this case, it would be num, right? So when you exit the loop, assuming you exit the loop normally, then I would be equal to num, right? But this is again no longer true in C99 as we discussed. Okay. Yeah. So for the previous exam one, no, we're not going to be deducting if you did for int I. Yeah, because I'm completely agree that you were not aware of this, and it's a subtle difference. So definitely on the first exam, we're not going to be penalizing for that. If you see any points deducted, file a grid inquiry. Okay, quote me. Okay, for same for homework assignments. As long as your homework code compiles by GCC, it's fine. Okay. Okay. What happens if you don't declare int I outside of the loop? Like I said, depending on the version of the language, if of the standard, all right, if you're not using C99 or newer, then it's your code is just not going to compile. It's going to be a syntax error. If you're using C99, you can totally do this declaration. So let's see. Do we have any? Let me pause here. Do we have any examples with for loops coming up? Those are while loops. Yeah. All right. Anyway, we will have examples of for loops for sure. Okay, and you will see that it works. So if it compiles when we declare I in the loop, yeah, you would be fine. Yep. Okay. So and yeah, here we are doing. We are working with structs. So this example shows how to deal with structs, and it the beginning of this code reminds our previous example. So we're just opening the file and we read the contents of the file, but instead of printing what we've read and scanned right directly to the output, we want to store this data in a struct. So here's our struct defined with type def. So that we want, and the reason for that is because we want to use this shorter name person rather than, keep saying struct person all the time. Okay, so we defined our struct as and gave it, a custom shorter name, just person. Okay, so we read the file, we parse each line as before, and then we declare this variable. It's static, so it's going to be the memory for this struct is going to be allocated on the stack, right? Because we are inside main method, and then we initialize this struct with the values that we read from and parsed from the file. So we str copy the name, we set the age, we set the height, and then finally we print values from the struct just to make sure that they are correct, right? Because we want this to be a separate function, and it makes sense, right? Try avoiding huge functions. Try to structure code so that each logical piece of functionality is handled by a separate module, and because we are in the imperative paradigm, the module would be a function, right? So here we have this function print info that takes a pointer to a struct, to our person, and just prints the values. Somebody asked me last time, do we use this dash greater, the arrow operator in C? And yes, we do, as you can see from this example, right? If P were not a pointer but a struct, we would use a dot to access its members. If P is a pointer, we use this arrow operator to access its members. So this aspect is exactly the same as in C++. So we printed the data in our struct. We have to use the ampersand because here we have to take the address of our struct, right? So person is not a pointer, it's a struct. So if you want to pass it, if you look at the prototype of print info, it says person star. So we have to take the address, and that's why there's an ampersand here. And then we demonstrate how the same code would look like if we wanted to do dynamic memory allocation with malloc. So first we have to allocate the memory, and we need to tell malloc what the size, how many bytes to allocate. So for that we use sizeof. Sizeof computes the size of the number of bytes required to store data for a particular data type or for a particular variable, right? Each variable would have a data type, so it's you can do either. And here it would be just this 256 plus however many bytes int takes and however many bytes float takes, and sums them up, and that's the return value of sizeof. Then we do the same. We str copy to our struct. All right, struct now is a point. So this a person on heap is a person star. It's a pointer to a person, right? Because dynamic memory allocation gives us a pointer. So it's most convenient to store this variable as a pointer, right? We cannot do this because this would imply static allocation. And of course, you could take the address of a person and do something with it. But this is how you typically deal with a dynamic memory allocation that returns a pointer. You store it in the variable that itself is a pointer. You str copy the name. You assign the age, and then you assign the height, right? So you need to use the arrow because it's a pointer, but the alternative is you can dereference the pointer so that it is no longer a pointer, and then you can use the dot as this example shows. It's a little unnatural in real code. People do not do this, right? Because it's by far easier to do this. But it just shows that, yeah, you can dereference and then you can use a dot. Or without dereferencing, you just use this arrow. And then you print info, you print the value. Okay, and let me look at. So pointers can point to just one thing and to the first element of an array as well. Well, pointer is just an address in C. So if the pointer points to a variable, it points to the first location of the first byte of where the value of that variable is stored in memory. And it doesn't matter if it's an array or if it's not array. It's the first byte that this variable occupies. If that or that data occupies. If the data happens to be an array of characters, that would be the first character. If it's an array of integers, that would be the first byte of the first integer. All right, let's. So what was that example? Once again, I/O with structs. So IO with structs. 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 Oops. And the file with the data, and you can see that. Yep, we have read the data from the file, and each line we stored twice in a statically allocated struct and in a dynamically allocated struct. Of course, the data is the same, and we can verify that. All right, so back to memory allocation. So we have seen how malloc works already on multiple occasions. There's also, and so with allocation functions, they're referred to as malloc family or malloc and the friends, right? Because there are several allocation functions that all allocate memory, but have slight differences in how they work or what they provide. So particularly, there's a version of malloc called calloc, and it allocates the memory, but it zeroes the bytes in the memory chunk that it allocated, which malloc does not do. And if you look at their signature of calloc, it's also slightly different. So malloc requires that you give it the number of bytes to allocate. Calloc breaks it into two pieces. It says how many members you want to allocate and the size of each member. And there's no magic. Calloc basically multiplies these two values and then allocates the memory, of size times n mem, right? So, but it's just slightly different signature. Calloc also allocates. Yes, definitely, absolutely. So you use calloc if you mostly, for the most part, you use calloc if you want to make sure that their memory chunk that is allocated has been initialized to all zeros. If you don't need that, use malloc. All right, but calloc can be convenient. How much longer does calloc take than malloc? A little bit, because it does some extra work, but no, it's really insignificant, because when it zeroes the memory, it can be done very, very fast. All right, so it's marginally slower, but I wouldn't worry about it, honestly. Is this O notation different besides just a constant? No, because it does have to allocate. It does have to zero all locations, right? So their amount of time it takes would technically be O of their total number of bytes it allocated. Okay, but like I said, their absolute time that would be spent doing this is negligible compared to the process of allocating the memory itself. So it's a very in real life, don't really worry about it. Yeah, and usually it's your choice. You can you're free to use calloc, even if you don't care about whether memory is zeroed or not. Maybe you just like it, that you have to specify the size not by one variable but by two variables that are later multiplied together. It's up to you. So free, we have already seen it deallocates or frees the chunk of memory that has been previously allocated. So it takes a pointer and make sure that it's the pointer to something that has been allocated before and not deallocated afterwards. And realloc, re kind of hints that it's gonna, do something over or redo something. It actually allows you to change the size of the memory that has been previously allocated. So it allows you to grow the memory that has been previously allocated. So you specify their size, this extra size, and the new size, and it attempts to change the size to what you specified. So the new size can be both larger or smaller than their previously allocated size. So if it's smaller, then basically you lose the size that is now outside of your allocated region. If you're trying to call realloc and get more memory than originally allocated, then for one, this call may or may not succeed. Right? Maybe there's just no more memory, and this call may fail. And if it is successful, then you will get, the pointer stays the same, but the pointer actually may change. Sorry, the pointer may stay the same, but it may change. So if realloc can allocate more memory to you uh, based on the region that has already been allocated, it will do it. But if it sees that in the contiguous memory, there is no way it can allocate sufficient size that you're now requesting. It will actually allocate, but there's still, somewhere else in the memory, there is a chunk large enough to satisfy what you're requesting. It will actually allocate that size in another memory location, copy all their contents from their chunk that you previously were given to the new location, and then give you that new pointer. Okay. So it allows you to, kind of grow their allocated chunk of memory, if it is possible. Okay, which take pointers to structure. Yeah, so totally, you can use you can use realloc to do stuff like vectors, or other stuff that you're familiar from C++. Totally, yeah. Create pseudo methods, definitely. Yeah, you can do that. It's just vector is by itself not part of standard C. If two blocks of memory are next to each other and then you call realloc to resize one of them, it would need to add is being used by the other block of. Yeah, so if there are two blocks next to each other and you're trying to enlarge one of the blocks, and there's no room, it will actually allocate their memory for that block, that you're now requesting to have a larger size somewhere else, as I just explained. Is that making sense? Let me know if it wasn't clear enough. Oh, why is the language C called C? Well, because it is based loosely based on the language that was called B. Yeah, and it's not a joke. Yeah, so that's the history of it. Um, so if there is enough cumulative memory to realloc, but not the required amount all in one, it will fail. Yes. So it will all, both malloc and realloc and all allocs will allocate a contiguous portion of the memory, a contiguous chunk, right? So it cannot be fragmented. And that might be the problem, right? Exactly as you noted, because if you look at the total amount of free memory that you have, it might be a significant amount. But if you are trying to allocate, something for you, if the amount that you are trying to allocate is larger than the largest of the pieces, it's going to fail, right? So if your memory becomes very defragmented, right, when you actively allocating freeing, and then your memory will be just fragmented. So you will have pieces of allocated memory interleaved with freed memory, but those non-allocated pieces would be relatively small, and then your alloc, malloc, calloc, whatever, would fail just because it needs a contiguous chunk of memory. What about A? I'm not actually sure. I don't think there was actually a language called A. I could be wrong. There was a language, an early language that was called APL, App Programming Language. A very creative name for language. App Programming Language (APL), and it was very, very popular in the 60s and to the 70s. But the amazing thing is, it actually exists even now. And so there's a British company that makes a compiler, and all the tools for APL, and it is being used in scientific computations, quite extensively. So despite the fact that it's probably, this language has to be like, my guess would be 60 years old, if not more. But it is still alive. It still has a community of users, and it's very, very special. It has, it's not using. It's using a lot of fancy characters that no longer exist on keyboards. So yeah, it's a very cool language if you ever get a chance to look at APL. Yeah, I used to know it a little bit, but I probably lost most of it. Okay. So that's memory allocation. And here's an example that we already looked at with our structs, where we are allocating memory dynamically for our struct student. And in the example, it was struct that we type deft to be a person. All right. So moving on, input and output in C. The only way to do input and output is through functions. There are no streams, so you cannot use, and we mentioned this before, you cannot use cout, you cannot use cin. There's no overloading of operators, so those operators are not overloaded, so they do not mean input and output to the stream. So we use functions, scanf for input, and the friends like scanf or fscanf. So scanf is also a family, and printf that we have already seen. So their first argument of scanf and printf would be their format string that specifies their required format. That format string syntax is mostly the same between printf and scanf, but there are some slight differences. So please make sure to review the documentation for printf and scanf or scanf to see what those differences are. All right, and then the remaining variables, the remaining arguments are just variables that or expressions that are printed, or for scanf they have to be variables that will be assigned to based on their input from their console. Okay, and on the homework, can I use fscanf? Yeah, totally. Yeah, cout, with a chain of those chevron characters. Yeah, forget about it. Sorry. All of a sudden, you like data structures, I guess. And C++. There's a question about scanf. Do you need at for strings? I've seen at used for other variable types, but not strings. The rule of thumb is you have to give a pointer to a variable to scanf. And that's why if you have something like an int I, you have to do %I, because you have to supply an address, you have to supply a pointer. If your variable is defined as character star, then it by itself is a pointer. That's why when you pass it to scanf, you don't need to to take the address of it, because otherwise it would be double reference, right? Double redirection. It would be a pointer to a pointer. You don't need that. Okay, so and here are some common formatting characters for printf. So D we discussed, it's a decimal. LD is for long decimal or just long. LLD is for long decimal or integer. So this D is really, stands for decimal, but it's for whole numbers. Let's put it that way, right? So on the exam, you had to output long values. So you were supposed to use LD, but since we haven't discussed it, if you just put D, it would be fine. There would be no deduction because of that. And U for unsigned. X is for hexadecimal. And please, uh, try to remember this X because we will be dealing with hexadecimal numbers a lot in this course. So you've got to love hexadecimal and binary notation. So X is for hexadecimal, F is for double, and S is for string, and scanf basically the same except for uh, F is used for both float, is only used for float. LF is used for double. Again, on the exam, there was one case where you had to use scanf to read the double value for the weight of the puppy, and you were supposed to do LF. If you just did F, it would be fine. Yeah, and if you had a chance to compile that code, the compiler would immediately tell you what flag to use, right? Unfortunately, we there's no way I can allow people to use compiler but not the internet. So that's why we are we are flexible. We're not going to penalize for small things like that, right? I think I did %L for long. Is that okay? Yeah, yeah. Especially on the first exam, it's going to be fine. I mean, probably we might, for some formatting that appears over and over again across multiple labs and homework assignments, we probably going to expect that you learn what they are towards the end of the semester. But something that is not used as often, or something that and especially on the first exam, we're not going to be picking. Yes, so %F on printf is used for both float and double. Yep. So that's one of the differences between printf and scanf. In scanf, %F is only for float, and for double you need LF. And it's confusing. I totally agree. Right. So. All right, and here are some examples. So again, U is unsigned, and F is a fixed precision floating point number. Here's an example for scanf, and yeah, so hopefully pretty self-explanatory. For some reason, the compiler still wants me to use LF for double. Is it in the printf or in the scanf? Printf. Okay, I need to double check. I'm not exactly sure. And yeah, please Kenner, ask this question on the submitty forum to make sure that I follow up. Right, because it might just get buried, in the chat, and I might forget. So if it's on submitty, either one of the TASO mentors or one of the other students would respond, or myself. Okay. All right. So header files, we need to include them if we want to use a certain functions from the standard library or not the standard library. So of course you can make, you can split your own code into multiple files and then include, one file in the other using this hash include mechanism. So for the standard library, stdio contains things like printf, scanf, the file, data type, and the like. Stdlib has different functions like conversions, string to long, string to decimal, string to double, and so forth, random number generation, allocation function, malloc and the friends. UniSTD contains system calls like fork, exec, and we will use those in a little while. Math-H, float-H, math routines. We have already seen math-H with SQRT, and error number, standard error numbers for return values for those things that you return when your main exits, right? So there are conventions related to what those numbers are. Zero stands for or exit success stands for successful completion, and other values, other constants correspond to different errors, and they are defined in this uh, arrow number.h, ERRNO.h. Is exit one enough for homework one error message return, or we need to use errno? Well, it's we're not going to penalize you if you do exit one. We prefer that you use named constants, not just magic numbers, but there will be no penalties for that on homework one because we don't mention it in homework one. Okay, and this is something that we have already talked about. C only passes arguments by value. If so there are no references, we cannot use this C++ syntax in C. So if we need to pass by reference, we have to take care of that ourselves. We have to use pointers, and this example we have already seen. All right, so now there are a little more complicated stuff. Pointers and arrays and dynamic memory allocation. So we can define an array like that, character array 4, it's statically allocated, and it will have a specific, very easy format in the way the array is laid out in memory. If we want to use dynamic memory allocation, we could be a little bit more flexible and define our array as character double star and treat the array as an array of arrays. And then we would have to allocate the memory for 4 pointers. So this is our first malloc. We are allocating memory for 4 pointers, right? So that's why we have size of character star. And we discussed that we don't really need to cast the return value of malloc, but we can if we want to show that the return we are allocating memory for an array of arrays, or a pointer to pointers, to an array, a pointer to an array of pointers, right? That's why we put that char double, character double star here. And that does not allocate memory for the rows of our array, right? It only allocates 4 pointers, so we have to allocate rows separately, and we do that in this loop. Okay, and we can use this subscript notation with brackets as we would normally with an array. So array sub I, right, would be the pointer. So it would be one of those 4 pointers that we initially allocated, and then we assign a pointer to to an array of characters, right? And in this case, it's also 4 because we're trying to match our previous example with a statically allocated array 4 by 4. Okay, so do we need to use terminate sign after a pointer? So their null character needs to be at the end of their at the end of their the array of characters. Okay, so so each of those array i's will need a null terminator in the end. But this array is a pointer to an array of 4 pointers, and for pointers you don't need a null terminator. And we'll see the diagram. So is the address of array, element 2, is the same in both cases? And the answer is actually no, because their memory structure will look very differently for the first and the second examples. Okay, so that is, yeah, it's not really a pop quiz, right? Because there's no, there's no poll for it. But here's what memory looks like for our statically allocated array, right? So it's a linear, contiguous series of addresses, and so, well, I'm jumping a little bit ahead, right? So I'm in here, right? So here's what our statically allocated array 4x4 is like, right? So it's a contiguous, chunk of memory that first has all columns of the first row, then all columns of the second row, and so forth. And the variable a itself is a pointer that has the address of this first element. Okay, so this is actually a very important slide, because we will use the conventions that are listed here throughout this entire course. So memory can be byte addressed or word addressed. So the address of the memory, you always have to specify, does it mean the address of a byte or the address of a word? So we would say memory is byte addressed or memory is word addressed. A word is just a certain multiple of bytes. It depends on the architecture. So they used to be, 16-bit words, 2 bytes. Now we are mostly into, 32 and predominantly 64-bit words. So if you're on a 64-bit system, the word is 8 bytes. And memory is just a linear sequence of addresses, right? And each address can store the value. So if memory is byte address, each byte is addressed separately. If memory is word addressed, each word is addressed separately, but there is no way to address the byte within a word. So you can only read a word or write a word if your memory is word addressed. And the byte order is different. It can be little endian or big endian, and we will talk about this as well. Yeah, big endian. It's like from their, from their famous book, right? So let me. All right. So what do I mean when I'm asking ampersand array 2 by 2, 2 2? So this is array 2 and 2, right? This refers to a memory location. And if I take the address of that memory location, I'm wondering if it is the same for our statically allocated array and our dynamically allocated array. Okay, so that's here's a note here on this slide saying that this ampersand operator is applied to take the address of a variable that is a symbol in in a program. So if you do ampersand array or ampersand array 2 2, those are not going to be the same. Okay. All right. So that's what their memory allocation looks for a statically allocated array. So, and when we say memory allocation, right, it is not a mistake. Memory is allocated for this array. It's not allocated dynamically, it's allocated statically when your code compiles, but still memory is allocated, meaning memory is reserved for this array. And it looks like that. And this would be in the stack, because it's statically allocated at the compile time by the compiler. And for the dynamic memory, where we used malloc, their memory layout is going to be like that. So our A will point to this A0, so the first pointer. So you see we have an array of 4 pointers, and each of those pointers points to an array of characters. So those yellow, green, red, and blue. Okay, and you can see that this array is contiguous in memory, and each of those arrays is contiguous, but they're not guaranteed to be contiguous, like as as this whole thing. Let me. So this whole thing is not guaranteed to be a single chunk of memory. So this piece is guaranteed to be a single chunk. This piece is guaranteed to be a single chunk. This piece is guaranteed to be a single chunk. All right, this whole thing. Okay, but not the entire rectangle. Whereas in the previous example with this, the statically allocated array 4x4, this whole thing is guaranteed to be a contiguous, a contiguous memory location. All right. So yeah, and that gives us some freedom. Each row can have a different number of elements because we are defining in code how each row is allocated. Here it's the same for all rows, but it can be different as this example shows. So static fixed, dynamic not fixed. Yes. So static means their memory is allocated at their compilation stage, and the compiler needs to know how much memory to reserve. Dynamic means the memory is allocated when the code is run, so their their amount of memory to reserve only needs to be known when the code is run. It doesn't have to be known when the code is compiled. However, their dynamically allocated memory, that's a very important thing to remember, is that when you allocate memory, you have to specify how much memory you want to allocate. And then this amount is fixed. Right, so it's not like you can grow this for free, right? If you want to grow their allocated region, you have to call realloc, right? So again, it's very different from C++, where you can just keep adding stuff to vector without thinking how it internally manages memory, right? It will allocate memory behind the scene, right? You don't have to worry about that when you just use vector. It's not like that in C, right? In C, if you allocated 50 bytes or 150 bytes, whatever, that value 150 or 50 can be supplied by the user directly or indirectly. But once you allocated the memory, you have that allocated piece, 50 bytes or 150 bytes. Unless you reallocate, it's not going to grow dynamically. Is dynamic memory advantageous because it's more flexible? Yes, it's more flexible because it allows you to know, how much memory to allocate at runtime. Right? Imagine you're reading from the file. You don't know at compile time how many entries, how many rows are going to be in this file. So it would be very problematic to statically allocate, enough memory to store the entire contents of the file. Whereas, with dynamically allocated memory, you can certainly do that. Yeah, dynamic memory is global, so it can be accessed outside of the scope it was created, as someone mentioned, because once you allocated memory, you have that memory available to you until you free it. With statically allocated memory, statically right, means by the compiler, and it means that it's local to a function. So as soon as you return from that function, the stack is cleared. So anything that was allocated on the stack is going to be gone. The heap can also hold more info than stack. In general, this is true, right? So typically, compilers have a limit on their amount of stack they can allocate, and this limit is usually pretty generous. So 1 megabyte, 1 megabyte, 2 megabytes are typical values, but still, it's relatively small. Heap memory, dynamic memory, gigabytes are typical, right? It largely depends on the amount of memory that you have installed on the system where you run your code. That largely determines the amount of heap memory that is available to your program. So yes. All right. So that was our pop quiz and function pointers. So this is the idea that similarly to how we have variables that can hold data, we can have variables that hold pointers to not just structs or other variables, but also to functions. And you will spend a lot more time with functional programming in the programming languages class that if you're a CS major, it's one of the required classes that you will need to take. All right, so functional programming is big these days, and largely C and C++ are not functional programming languages, but they have some features. Still, you will later learn in programming languages that truly functional programming languages treat functions as first-class citizens, whereas not non-functional languages lack this ability. So they do not give the same treatment to functions as they do to other data types, and that's why we say that for C and C++, functions are third-class citizens. Okay, but one of their features one of the few functional features that you have access to in C and C++ is the ability to have a pointer to a function. All right, so here, there's an example on functional pointers. If we run out of time, please make sure you review this example yourself. It's in the course materials. For now, those are typical program segments in any C program. So we have stack, which is used to store local variables. It is statically allocated always by the compiler. So the compiler will compute the amount of memory needed for a function call based on the parameters of the function and all the local variables in that function. And then heap is our dynamic memory. That's where malloc and the friends allocate memory. Heap and stack usually are next to each other, and they grow in opposite directions. So stack will grow down and heap will grow up towards the stack. Then we also have a data segment which contains globally statically allocated data, but global, not data that is not within any of the functions. Okay, so if you have a statically allocated array defined outside of any methods, that would be in the data segment. And yes, it's going to be on the next test for sure. Actually, if you look at their exam 1 practice problems, some of those problems were on this material exactly, but since we didn't cover them, they were moved from exam 1 to exam 2. So then text. Someone is. Okay, can someone mute themselves?
Give me a hug, honey.
Selves, please.
Did you miss your mommy? Yes. She gave me a kiss. So what's going on? Something's going on. No, something's going on. Oh.
Sorry about that. Okay, so text code segment, it contains your code, so the compiled code of your program, and all their constants, including all your integer values that all your literals, like you specify 256 somewhere, and it will be in directly encoded in your code, and all their string literals, like you have hello world in double quotes, that is going to go in their text code segment as well. Okay, and here's this pop quiz that hopefully is reminiscent of the exam. So we have this term array, and so the exam was asking which is it global or local, and is it statically allocated or dynamically allocated? Hopefully you all answered that question. But now that we talked about memory segments, can you tell which segment this term is going to be located in? And let me open that poll now. So it should be open. Okay. Yeah, I'm not gonna. Yeah, I'm not gonna share the correct answer now, because there is a correct answer, right? And it determines whether you get a full point or a half a point. But we will of course discuss it next time on Tuesday. And in the meantime, all right. So this is the function pointer syntax. This is and the syntax is kind of weird. It looks strange to me, at least. I don't know if you agree or not. But if you need to define a variable, so you can either define it directly, or you can first define their type, as we do in this example. So we type def function pointer t. T stands for type, but this is just a convention. So that would be the type of that we are introducing, and the type would be a pointer, hence the star, to a function that takes an integer, and you can see it from here. So it takes an integer. It's a pointer to a function, and this function returns an integer. So this, if we have a variable of this type, it can point to any function that matches this definition, right? Any function that takes an int and returns an int. And now we use this type that we defined. So this function pointer t, this is the type, and we define the variable. So the variable is sqit ptr, and then we assign the value to this variable, and the value is the address of the function. So square it is a function. So we take the address of this function, cast it to our type function pointer t, and assign it to square it pointer. And then square it pointer can be used as a function, right? So we want to call whatever function is stored in this pointer, we just use the name of the variable, which is a function pointer, like that. Okay, we type def a function. No, we type def a function pointer, right? So this function pointer t is the data type, and we can define multiple variables, but any of those variables that we define as having type of function pointer t will hold an address of a function that takes an int and returns an int. Why do we have pointers to function? They are very convenient. Imagine that you are asking your user at runtime, oh, do you want to square this value or take a square root? And then depending on what the user answers, you want to produce, you want to perform the required action. So this way you can have, your pointer variable to be assigned a point to the correct function based on the user input. And then once this is done, you don't have to worry about anything. The rest of your code just uses this function, knowing that it will be pointing to the correct function that needs to be executed. So that that allows you to write very general code, right? So it can be very convenient. Or an array of functions. That's another great example. Yeah, in a sense, this is like a precursor to the idea of polymorphism, if you will, right? So you can think about this pointer variable as being polymorphic because it can take multiple pointers to different functions, but there has to be something in common between any function that this pointer can point to. It has to be a function that takes an int and returns an int. So why not just call other square it? Well, because if you call square it, you always call square it. If you call square it pointer, if it happens to be if it happens to have a pointer to a different function, that function will be called. So you see, you're getting this flexibility. This flexibility is not exploited in this example, right? So this example is very basic, right? It just demonstrates how to, how to handle, functions in function pointers in general. But yeah, so in C#, it's delegates exactly. Yep, absolutely. Because C# doesn't have pointers, as such, regular C pointers, but pointers can be very convenient. So in C# they came up with delegates exactly. All right, yeah, so this hacking your stack refers to an example that, again, I don't know if we have time today to go over, but you can review that example. It is this function pointer example with a little hack that actually allows you to supply assembly code, which we will talk a lot more about. So please review this code just for fun, just as the first immersion into their x86 assembly. Yeah, you can supply this code and actually run it. So you can put this code on the stack and run it. So it is totally possible. So that's this example. All right. So next topic that we are starting. Yeah, let me just take one question. What happens when we call square it inside the main? Well, we don't call square it. We call their function through the pointer. So it's like an additional level of redirection, right? Instead of calling square it, we call the function that is pointed to by a pointer, whatever that function is. We know that function has to be a function that takes an int and returns an int, but it can be any function. What is the difference between data and stack? Data holds data that has been globally allocated outside of any function, and stack holds values that holds variables that are local to a function. So local variables and formal parameters. If we want a square it to take an int and return a double, how would we write the type def? Well, instead of int, you would write double here, because this stands for the return value. And then, of course, you would have to do double here, and that's it. And then you would have a variable. You might, you would probably want to assign the value returned to something. So you would write like double a equals this sqit pointer. Stack holds mostly variable in main function. Not exactly. Stack holds variables in any function, not just main. Main is a function, but there might be other functions as well. All right. So to access, now we start talking about Unix systems because we we'll be doing some stuff that is specific to Unix systems, and generally Unix systems are very common. So if you haven't had a chance to work with a Unix box, this is the right time to do it. So please make sure you have access to some Linux Unix system. One way or the other. Let us know if you need help installing it on your machine. So, similar to Windows accounts, if a user needs to work with a Unix system, they need username, password. But there are a few additional things that are specific to Unix systems. So let's review them. And here are more names that you can Google, for guides and tutorials on Linux and Unix. So username is the name of their user. So typically it's a sequence of alphanumeric characters, and that's their primary identifying attribute. So if you're logging into the system, that's what you enter, as your name. That's how you introduce yourself to the system. And then internally, Linux systems would have another data element called user ID that we will talk about in a minute. And of course, password. I'm sure you're familiar with the password, right? So it protects their account from unauthorized use. So it's a secret string. And then user ID is something internal to Unix system. It's a number that is associated with a Unix account, and each user ID is unique. Yeah, we don't usually need to worry about user ID, but in some contexts, it is important to know that their system, the Unix system itself, identifies users not by usernames but by user IDs, right? But in some instances, it's by username, right? If you look at their password file, it's going to be by by username. And in addition, there are also groups and correspondingly group IDs. So a group is a collection of users, and each user is assigned to at least one group called a primary group. But they can also be members of any number of additional groups. And each group has a name similarly to a username, and it has an ID similarly to a user ID. So here's our next pop quiz. To log into a Unix system, you need which of the following? So let me open that poll. All right, a home directory is a place where, so it's like a user profile on a Windows system. So it's the place where the user is supposed to store their files. And a directory is is the concept that is similar to Windows folder, and many Unix commands and Bash and shell commands and applications, they make use of the home directory of a user. So that's yeah, that's a home directory. So a shell is like a command prompt in Windows, or a PowerShell. So similarly, in Windows now we have different shells. Like one is PowerShell, another one is command prompt. So similarly in Unix systems, there's usually a choice of shells, and you might have heard of Bash, which is a very common shell. If you're running Ubuntu, chances are you're running Bash as your shell. So this is basically a shell, an environment that allows you to interact with the system through a terminal by typing commands and observing the output that would be printed on the console. So it's a text-based user interface. So to log in, you have to be either physically at the console, or you have to access via the network through some remote access tools like SSH, and you would need to enter your username and password, which in most common Unix systems are case sensitive. So case does matter. And once you log into the system, it runs the shell and usually displays a prompt. It depends actually on the system. Some might just get you into their graphic user interface environment, run X server, and not give you a a terminal by default. But if you're connecting remotely through through SSH or something similar, then shell, this text-based shell is everything that you are ever going to get. So you need to be comfortable working with, with a shell, because if you ever access any Unix server, you're not going to get any GUI. You would have to use shell explicitly. All right, it is 1:50, so let's stop here. We are a little bit behind our schedule, but you're asking a lot of questions and good questions, so I don't think we need to be concerned, but we'll try to accelerate a little next time. Yeah, so for this lecture, so poll number 4 will be just part of the next lecture. We had 3 polls today, and my office hours are 2:30 to 3:50 p.m. In my MS Eaton office hours, in my MS Eaton 112 office. So as soon as I'm done with this call, I just gonna pack my things and head to campus for office hours. So hopefully to see you there. Thank you for attending this lecture. See you on Tuesday, and enjoy your weekend. Try to get the last few sunny and warm days, hopefully. Thank you, folks. Have a good one.